Good morning everyone. Yesterday we saw about the wedge shape film. Now we can calculate the width of a wedge shape film, thickness of the wedge shape film or the diameter of that particular wire inserted inside the two glass plate. Now first of all we will calculate the fringe width. The fringe width is denoted as a beta. What is the meaning of a fringe width? Fringe width is nothing but a distance between the two consecutive fringes or a band is known as a fringe width. It may be a dark band or a wide band is known as a fringe width. Now we can determine the value of a fringe width. For that one we will draw the simple diagram for a fringe width. Now our aim to calculate the value of a fringe width. Suppose we are considered the two glass plate OX and OY inclined with the small angle as a alpha. At one end is a closed one, other end we are inserted the sheet of paper or a thin wire, and there is a formation of a air wedge, and by using that air wedge those bands are formed. It may be a dark and a bright band. Our aim to find out the distance between these two successive bands. Suppose we are consider here AP and the BQ are the two consecutive fringes. Suppose the AP is the first or nth dark fringe which having a thickness as a T1, and the BQ is nothing but the second consecutive fringe, dark fringe which having a thickness as a T2. Now our aim to calculate the fringe width of that particular distance between these two particular fringes, that is n and the n plus 1th one. Now we will know that according to the wedge shape frame, the conditions for the dark and the bright fringes. For that one, suppose first of all we will consider the for dark fringes, delta is equal to 2n plus or minus 1 lambda by 2, that is 2 mu t cos of r plus or minus lambda by 2 is equal to 2n plus or minus 1 lambda by 2. So we will get 2 mu t cos of r is equal to n lambda, but here the rays are incident normally to that glass plate, that is why the value of cos r is nothing but 1. For normal incident the value of cos r is equal to 1. So we can substitute here, we will get 2 mu t is equal to n lambda and denote the equation number 1. Now here our aim to find out the thickness of that particular one. Here first fringe, suppose we are consider AP which having a thickness as a T1. So instead of T we can substitute as a T2, T1. So we'll the same relations we can write 2 mu T1 is equal to n lambda. Suppose equation number 2. Similarly for the next consecutive fringes, that is a BQ which having a thickness as a T2, that's why the T is substituted as T2, will get n plus 1 lambda, denote the equation number 2. Now we will take the difference between this T2 minus T1, n plus 1 minus of n fringes. So we can subtract the equation 3 and 2 from the equation number 3. We will get 2 mu t 2 minus of 2 mu t1 is equal to n plus 1 lambda minus n lambda. So we will get 2 mu as a constant factor, T2 minus T1 is equal to n lambda plus lambda minus of n lambda. So lambda lambda get cancelled, remaining factor is 2 mu T2 minus T1 is equal to lambda, denote equation number 4. But what is the value of T2 minus T1? This total one is a T2 and this small distance is nothing but T1. So T2 minus T1, remaining part is nothing but a BC part. So we can substitute the value of T2 minus T1 as a BC. So 2 mu times BC is equal to the lambda, and denote the equation number 5. Now our aim to calculate the value of BC. For calculation of the BC, we will consider here the one of the right angle triangle, that is BAC. In the triangle BAC, the angle BAC is nothing but alpha. So from the small triangle or in triangle BAC, our aim to calculate this distance of this BC and the distance of the beta, that is a fringe width. The relation between these two of the opposite side of the angle divided by the adjacent side of the angle, that ratio is nothing but tan ratio. So tan of alpha is equal to BC upon AC. So BC is equal to the distance AC is nothing but the distance of separation between the two fringes, that is nothing but a beta. So BC divided by beta, we will get that BC is equal to beta times tan of alpha. Now we will substitute the value of BC in equation number 5. We will get 2 mu BC as beta tan of alpha is equal to lambda. So tan of the value of beta is equal to lambda upon 2 mu tan of alpha. But here the value of alpha is very small, then we can say that tan of alpha is equal to the value of alpha. So tan alpha is equal to alpha. So the equation 5 become, equation number 7 becomes beta is equal to lambda upon 2 mu alpha. This is nothing but the fringe width of two consecutive fringes. So in a short, by using a wave shape film, we can calculate the fringe width between these two wavefront, two fringes. Beta is equal to lambda upon 2 mu alpha. After that, we will calculate the thickness Now we can calculate the thickness of sheet of paper or diameter of a wire. Now for that one, again we will consider the wave shape films. Here this inclination as alpha. Suppose here we are inclined O, A and B. So here OA and OB are the two glass plate, inserted the sheet of paper having a thickness as a T. This distance is nothing but a T. Now the distance from origin to that particular one is nothing but L. Then our aim to calculate the value of the thickness of a sheet of paper or a diameter of a paper, then we can calculate the value of T. Now for that one, we will consider the relation between again this side and this side with the angle as a alpha, that is alpha is a opposite side divided by the adjacent side, means that which ratio we will consider, that ratio is nothing but tan of alpha. Tan alpha is a T upon L. Again this value of alpha is very small, so the value of alpha, tan alpha can be write as alpha. So alpha is equal to T upon L. denote equation number 1. Suppose we can substitute the value of alpha from the fringe width, that value as a beta is equal to lambda upon 2 mu alpha. So, alpha is equal to lambda upon 2 mu beta. This value of alpha we will calculate from the fringe width, that is the relation between the fringe width and the angle of inclination or a wave shape as alpha is lambda upon 2 mu beta. Therefore, the equation 1 becomes alpha as a lambda upon 2 mu beta is equal to T upon L. Now, our aim to calculate the value of T. So, T is equal to lambda L upon 2 mu beta. That is a thickness of a air film in between the two glass plate, or a thickness of a sheet film, or we can say that we can calculate the thickness of a air wedge which is found between these two. 1 is equal to lambda, T is equal to lambda L upon the 2 mu beta. In this way, we can calculate the value of fringe width as well as thickness of a paper of sheet, diameter of a wire, and those things we are inserted in between the two glass plates. Then the anti-reflecting film. For that one, we will draw the diagram for anti-reflecting film as a glass plate with the some coating material which having a refractive index as mu 2. This coating material having a refractive index as a mu, and this one is second media air which having a refractive index as a mu 1. Now, draw this ray AB is incident on this one, there is a partial reflection and internal reflection and emerge out R1 and R2, A, B, C, D and R1 and R2. Now, here we will consider the glass plate coating with the some material as a magnesium fluoride, we can coat it on that surface. The thickness of that coating material is nothing but lambda upon 4 times mu, where mu is the refractive index of a coating material as a magnesium fluoride. Now, here when the rays are AB is incident on the upper portion of the film, then we are consider the intensity of incident ray as IR. At point B there is a partial reflection and a partial reflection upon BC as well as reflection upon PR take place. Now, the intensity of this refracted ray is considered as IR. Then according to the Fresnel equation or according to the Fresnel, the ratio of intensity of refractive light to the intensity of incident light is nothing but mu 2 minus mu 1 upon mu 2 plus mu 1 its bracket square. This is given by the ratio of IR upon I, that is the intensity of reflection due to the incident light and the ratio of intensity of incident light. That ratio is equal to the refractive index ratio, that equation given by the first of all Fresnel. Now, the non-reflecting film is also known as a anti-reflecting film. Non-reflecting film, what is the non-reflecting film? Non-reflecting film is nothing but the reductions of reflected light is known as a anti-reflecting film. That anti-reflecting film can be deposited on the glass plate with the thickness as a lambda upon 4 mu, where lambda is the wavelength of incident ray, 4 mu is 4 as a constant factor, and mu is nothing but a refractive index of a coating material. And this thing first invented by the German physicist as a Smakula. Smakula invented this first of all the reductions of a reflected light. According to him, the 4% of light can be reflected from the anti-reflecting film or non-reflecting film, and the remaining parts can be transmitted. That is, a 96% light can be transmitted through that one. And suppose we have to calculate the thickness and conditions for that reflected light. The first condition is known as a phase condition, and the second condition is a amplitude condition. In a phase conditions, here we are consider AB as an incident ray reflected partially along this direction BR, and along the direction BC, which is a refracted. Along CD again there is a multiple reflection, and DR2 is the emerge out. So we will get a 2 reflected light, and then the part difference between these 2 rays is nothing but the delta for bright fringes is equal to n lambda. So 2 mu t cos of r plus or minus lambda by 2 is equal to 2 n lambda. So we will get 2 mu t cos of r is equal to 2 n plus or minus 1 lambda by 2. Now again here for normal incident, the value of cos r is equal to 1. So we will get 2 mu t is equal to 2 n plus or minus 1 lambda by 2. If the value for air media as the mu is equal to 1 and the value of n is equal to 0, so the same thing we can write 2 mu t is equal to n is nothing but 0. So this factor is a 0, we will get lambda by 2. So the part difference between these two reflected light, bright light, is equal to 2 mu t is equal to lambda by 2. So delta is equal to lambda by 2, or mu t is equal to lambda by 4, or t is equal to lambda upon 4 mu. So the how much thickness can be given or deposited on this glass plate is a lambda upon 4 mu. This is calculated from the conditions of bright fringes as well as dark fringes. Now what is the phase difference? The phase difference is equal to 2 pi upon lambda multiplied by the part difference. What is is considered as a 1 for the air one. So T is equal to it's that there is a phase abrupt light. So this delta or pi is degree, or pi indicates that there is always phase change of a pi or abrupt phase change, and the second condition is nothing